Hey, you all, Farmer Jesse here. Welcome back to the No-Till Market Garden Podcast Summer Short Series, which we've got like 3 more of these until we take a break in September. And then we get back to long-form interviews this fall for Season 3. Excited? Me too. But we've got some great stuff first. This week I caught up with Nigel Palmer, who just published a book through Chelsea Green called The Regenerative Growers Guide to Garden Amendments, using locally sourced materials to make mineral and biological extracts and ferments. And I wanted to talk about gathering one's own amendments with Nigel, what the limitations of that are, and a whole lot more. Definitely could have gone on longer on this topic, but the good news is Nigel wrote an excellent book about it. But first, we are inching so close to our $2,500 goal for the summer at patreon.com/farmerjesse. Much of that money goes towards creating content, keeping our site going, and paying some people to help me. It is a critical part of this work, and if you love this podcast, consider chipping in a couple bucks a month over there, like $2, $5, because that helps us out, and at a certain level, or if you just bump up from one level to another, you get a shout out on the show. So big shout outs this week to Amber O'Neill, Andrew and Haley Keeler, Francis V, Jody Miller, Aslan Organics, Travis and Heidi of Arcadia Acres, Kevin Keene, Ryan Gosser, Jean-Martin Fortier, Yannick LaPlante. Huge thank you to all of our show supporters. Like I said, that fund at patreon.com/farmerjesse is a huge part of what makes this possible. Or, if you prefer, you can always just kick us a couple bucks at Venmo to @notillgrowers to say thanks, y'all. We appreciate that as well. One quick note on the audio. My dog is barking. One quick note on the audio is the first minute is a touch choppy, but we fix it quickly. Anyway, that's enough for me. Let's get into this amazing conversation with Nigel Palmer from the Sustainable Regenerative Gardening Program at the Institute of Sustainable Nutrition. Nigel Palmer, thank you for taking the time to chat.
My pleasure.
So you wrote this new book, The Regenerative Growers Guide to Garden Amendments, and I think it's really great. And I'm wondering if we can start by talking about the basic differences between local microbiology and bottled microbiology. What's the extent of our incentive to collect our own indigenous microbes?
Yeah, that's a great question. There is really no comparison. The local biology is far more diverse and rich in quantity and numbers compared to the bottled. To start with, we only know the names of about 10% of the biology or fungus that are out there, and archaea is a life form that was identified in the 1990s as a ubiquitous life form in the soil. When we go and buy a bottled biology, as you call it, or the inoculants in packages, usually they list a handful of bacteria or fungus on the label, and these are often dormant or in some other form so that they can send them and package them. They're nowhere near as diverse as the local biology. It's unclear what they really are in comparison to what's in the soil, and it's unclear how they will prosper in the soil. Whereas the local biology has thousands or even more bacteria, fungi, and archaea available, and it's just a total ubiquitous mix of biology that you just can't compare to anything that you'd buy in a package.
So you mentioned that word archaea, and you emphasized it here, and then you also emphasized it a little bit in your book. Can you talk about the role of archaea and what we do and don't know about them?
Sure. Archaea is a really great example of how much we don't understand about the activities in the soil ecosystem. Archaea was first identified in the 1970s in the geysers of Yellowstone Park. It was later found to be in the depths of the ocean under very high pressure, no light situations. And it was thought to be a kind of bacteria. Later, we found that it's an entirely different life form that was established in the 1990s timeframe, and we had to change the life that we understand. And what's really cool about it is that further study shows that it's ubiquitous. It's throughout the soil and responsible for nitrogen fixing and many other activities. what's very fun to think about is how little we understand about the soil microsystems, ecology. Bacteria, for instance, and fungus, we only know the names of 10% of each of those categories, and the interaction between bacteria, fungi, and archaea are far from understood. So not only is there some amazing diversity of life forms in the local soil, but there's also the interactions from them. And by providing this biology to the soil, it gives the plants the opportunity to selectively feed those which the plant seems to want or need. So it's just a fascinating conversation about the life in the soil and what we don't know about it. And so the thing to do is provide it and let the plants figure it out.
Are there limitations to local amendments? If I'm reading my soil test, are there things on there that I'm just not going to be able to get for free or cheap locally? Are there things on that soil test that I'm not going to be able to supply?
Yeah, that's another great question. The easy answer is I think that it's all available. It's just a matter of using one's imagination to figure out the available resources. One of the constructs of the book is to try and provide different resource ideas for people to use in their local area, whether it's the plants, whether it's a quarry dust or kitchen waste in the form of eggshells or ocean shells or the bones. Maybe there's a restaurant nearby that throws away oyster shells or clam shells. Perhaps there's a fish market around that throws away parts of fish, river silts, bogs. All of these things are different resources available to people, but we often don't think about them as mineral resources. I list many amendments and the minerals that are in them in an appendix in the book. And the purpose of that is to show that plants have, in most cases, all of the minerals that are needed, but they have them in various concentrations. So, for instance, dandelion, which is a pretty common plant found just about anywhere, has a beautiful spectrum of minerals available, the micro minerals and macro minerals. When we talk about macro minerals, we can think about eggshells or bones or rock dust. So it's really up to one's imagination to understand what's available in their backyard and then understand what each of those wastes, or in some case plants, have to offer. And I've tried to provide enough information where people can begin to think about that, and enough data in the form of analysis of amendments where people can see that indeed all of these things are available to them. They just have to use their imagination and go and get them.
And then a lot of what you're talking about in the book are things like foliar sprays. One of the things that I kind of still am trying to wrap my brain around is how plants utilize foliar sprays. Like, can you kind of make the case for foliar sprays and talk a little bit about that?
Yeah, sure. So foliar sprays have many advantages. I'll try and touch on a couple of them. The first thing is if you want to provide nutrient to a plant, either a biological nutrient or a mineral nutrient, a foliar spray is applied directly to the leaf surface, and that plant has the ability to absorb those nutrients in a matter of minutes and hours immediately through the phloem flow. The phloem flow is a flow in the plant sap that goes from the leaf to the different sinks, the roots, the new shoots, the fruits, and the root exudates. And so by providing a foliar spray, you provide nutrient that the plant can use immediately. This is a great way to thwart insects and beetles, for instance. So you've got a nice, healthy potato plant. The plant's sap sugar content goes down. It becomes more of a food source to the plant. And by being in the garden and seeing a potato beetle on your potato plants is an indication that things are declining. And so you could quickly apply a foliar spray to that plant and give that plant nutrient in almost real time to increase that sap sugar to thwart off those insects. It's an amazing concept to recognize. By providing nutrient to a plant in the form of a foliar spray, you can actually increase the sugar in the sap and make it more resistant to insects. The other thing is when you use a drench, like watering the soil of a plant, or when you apply rock dust or other, I'll call it hard minerals, a drench might take days to get into the plant root system because it has to get into the soil solution and then be absorbed by the plant roots. And rock dust have to break down in the soil and get into the soil solution before they're uptake by the roots. So foliar spray offers almost immediate absorption of the plant, and also regular scheduling of foliar sprays provides plants with the nutrients that are needed, especially when you recognize through a soil test or some other way that your soil is inadequate in some ways, or it has an excess in some ways. So you can dial in a foliar spray to accommodate those needs as well. So in short, one, it's immediate absorption, and two, it's a regularly scheduled nutrient regime for plants.
That's great. Can you give us a couple examples of foliar sprays that you kind of think are really effective in a general sense? Like I think of like lactic acid bacteria from sort of in the KNF style, or one of those. Can you kind of give us a couple examples of foliar sprays that you highly recommend?
Yeah. So one of the things that I recognized some time back was the best thing to feed a plant is the fruit of the plant itself. So, for instance, blueberry season is upon us, and those of us who are fortunate to have them are harvesting blueberries, and those of us that are busy often don't get to all of those blueberries, and we find underneath the blueberry bush there's a surplus of berries that have over-ripened or some other damage. So I take those and I make a fermented plant juice of the blueberry's fruit itself. Now I have the quintessential food source for a blueberry plant. So I'll make a foliar spray with the blueberry fermented plant juice itself to feed my blueberries throughout the season, specifically at the end of the year when there's still leaves on there and I have the opportunity to provide nutrients for the berries the following year. Now, in conjunction with that, you might recognize that different phases of plant growth require different nutrients. For instance, when filling fruit, calcium is a mineral that's extremely important to a plant. So a vinegar extracted eggshell or oyster shell has very high calcium content and could be added to that blueberry fermented plant juice to make a foliar spray that is not only dialed into the actual constituents, mineral constituents that blueberry plant might want, but also add the additional calcium that is specific to a particular phase of growth. So by recognizing these ideas, you can dial in specific foliar sprays for plants throughout its growing season. And again, this is why the data in the appendices of the book is so important, because it gives people an idea of just how these concentrations change from plant to plant, and examples of what could be added to facilitate those ideas. The other thing is you mentioned lactic acid bacteria. This is more of a biological amendment, and I've used the biological amendments in order to thwart airborne pathogens on leaves, whether it's a leaf mold biology or lactic acid bacteria. I guess the first thing to recognize is if you provide the nutrient a plant needs, it becomes healthy, and you generally don't have these kinds of problems. But in the instances where there are those problems, applying biological foliar sprays to the leaf surface provides competition for the biology that's causing a problem on the leaf, and has the ability to bring those conditions under control as well.
Yeah, that's great. And the fermented plant juice one I thought was really interesting. That idea of I think you say this in your book. It's basically like, the plant, when it creates a fruit around a seed, it's giving it a little birth package, like a little package of all the nutrients it's going to need to start its growth.
That's right.
And so by fermenting that and then reusing it on the plants, you're essentially giving those nutrients back to the plant itself.
Yeah, so why guess as to what a tomato might need? Why not provide a tomato?
Right, and then a lot of times we're cutting these quite a lot, right? Like we're talking about ratios of like 1 to 1,000, 1 parts, lactic acid bacteria or fermented plant juice or something like that to 1,000 part water. What's the value in cutting it like that? Is it can you easily overdo it, or is it expand? Is it just making the most use out of? Like, I've always been kind of curious about why we cut it by so much.
Yeah, I think it's a variety of things. Both of the things you mentioned. First off, is there's a homeopathic nature of these sorts of ideas, and so in many instances, less is more. So I think that's true, and I think also it's possible to overdo things, a balanced approach is one of value, and I think that time and practice is the best teacher here to see what your plants respond to. I'm always amazed sometimes when I provide a foliar spray and the plant response is absolutely astounding. To see a plant totally change overnight is just remarkable and a lovely thing to see. But yeah, I like the less is more approach, the more homeopathic approach to these things. And so I like to start with very small dilution rates just to see what happens. And it's really kind of a cool thing. So that for a home gardener, go back to the case of the blueberries, I got about a quart of blueberries that were otherwise damaged underneath my plants and fermented them. And I'll get about a pint of fermented plant juice. And if I'm going to dilute 1,000 to 1, that's 1,000 pints. So that's going to last a long time. So even when you scale these up to the farm and use maybe a 50-gallon container for fermentations, you're just going to end up with an awful lot of these products that will be able to last you a season or even more. And they're shelf stable and they're just about free.
Right. Is there kind of a general guideline for where to keep these in terms of shelf stability? I mean, you want to keep them away from pests, but beyond that, like in terms of temperature and light?
Yeah, that's a great question. I have some shelves in my basements where the temperature is pretty constant, out of the light, well ventilated. Some of the fermented leaf mold products that I make, I leave outside, and the only issue there is freezing in the wintertime. But the garden shed's a great place for those if it's not going to be too cold. But yeah, out of sunlight, well ventilated, constant temperature as possible. Those are pretty good guidelines.
So a big portion of your book is kind of dedicated to some Korean natural farming techniques and sort of adapting them a little bit more to our region. I often get this question about high desert areas and an IMO collection. Because you and you're in New England, I'm in Kentucky. We live in deciduous forest areas, but if someone lives nowhere near a forest like that, what kind of recommendations could you make for somebody to get an IMO collection in that circumstance?
Yeah, that's a great question. One of the things that I thought about when putting this book together was how to help people in remote areas that is not lush and green like the wonderful places that we live in, and how to help them to facilitate these ideas. And so even in the desert, there's going to be biology in the soil. Unfortunately, I have no experience with that, but I think trying things out is the best teacher. So I would recommend people give things a try. So if I was in a very arid area, I'd look for that one big old tree that's been there for a long time, for instance, or those shrubs or whatever life form was. And although it might seem silly and more of a long term, I'd start planting things in an area. I'd start planting shrubs and trees and grasses and anything that I could. There are plenty of stories that we can read about as references where people have planted 100 acorns a day, for instance, and other sorts of plantings that have changed an ecosystem. And so it might seem long term, but by planting seeds and planting different things in a specific area will facilitate that soil biology. And again, these sorts of things snowball. It's not 1 + 1 = 2. It's 1 + 1 = 10. And by moving along in these directions over what I call garden time or a longer term, will facilitate these sorts of ideas and these biologies, these ecosystems. Again, no silver bullets anywhere around here, but these are the long-term strategies that might work in those arid areas.
One thing that's been recommended is taking pinches of soil like from the forest and mixing those into your compost, and that's just a general recommendation. So what about something like that? Like if you get to a forest in a nearby area, bringing that biology, back to your farm and then doing some composting that way, maybe even in a KNF style. Do you have thoughts on that? Do you feel like that's could be a decent approach as well?
Yeah, I think that's a good idea. The one thing that should be recognized is that biologies in different areas have different abilities to compensate and survive in those environments. So one pretense is that the biology at a higher elevation will do well at a lower elevation, but the biology at a lower elevation may not survive in a higher elevation. So I think those techniques are great ideas, but I think they need to be taken with the knowledge of where are you actually taking this biology from and transplanting it to. And I think in conjunction with planting and stimulating the growth above the soil as well as in the soil would facilitate those ideas as well. As soon as you start growing things, and it doesn't even matter what it is, just growing anything such that the roots in the ground will decompose in the soil, increasing the carbon content. The fodder above the ground will lay fallow on the soil surface and break down and create a mulch. So all of these ideas in conjunction with each other. So you're building up humus, you're building up biology, you're building up ecosystem structure, will facilitate the ideas of changing the ecosystem in a local area.
That's great. Nigel, thank you so much for your time, and I want to wish you the best of luck on this book. I think it's excellent.
Well, thank you very much. I appreciate the opportunity to speak with you today.
All right, if you enjoyed that episode, you can pick up a copy of Nigel's book at tiosn.com. You don't have to memorize that. There will be a link in the show notes. Also, subscribe to this podcast wherever you're hearing it so that you are ready in the fall when we jump back into Season 3. Rate and review it as well. Why not? Thank you to Jackson Roulette and Josh Satin and Hannah Crabtree. Thank you all for listening. We'll see you next week. Bye.